So consider one ellipse shown here with its major axis along the horizon and a copy of it rotated 90 degrees about their common center. Okay. Now it turns out that if the aspect ratio of both ellipses is this number here, 2.870 blah blah blah, and this is a numeric approximation, you can close on n equals 7. Okay, so this is a heptagon, Poncelet heptagon, right? So in such a way that by virtue of Poncelet's theorem, you're going to get a continuous family. You're going to continue to close that n equals 7. So let's count the number of sides here. 1, 2, 3, 4, 5, 6, 7. So you do close. I try to close for other ends less than 7, but I haven't been able to. So there's two interesting questions here. First of all, can anyone derive an algebraic formula for this required aspect ratio, right? This is a 1 degree of freedom problem. What I'm trying to say is that at that aspect ratio, I will close Poncelet. Secondly, can I close Poncelet of higher ends, n equals 8, n equals 9, etc., etc., and what are the aspect ratios? Okay, so that's all I have.